Hey there everyone, welcome back to another video with me, Ben Rogajan, aka the Seattle Data Guy. Today we're going to be looking at a data infrastructure that handles probably exabytes, although the article refers to 1 exabyte of data. Specifically, we're talking about Facebook's data analytics infrastructure. We're going to look through their article that they put out in 2023. And honestly, as I reviewed this article, not a lot has changed since I worked at Facebook in terms of like what solutions they're using. So I can kind of give you some of the insights in terms of like what their data infrastructure looks like, and honestly how things are slowly starting to seep into more of the broader data community in terms of how people are picking up some of the patterns that are existing in Facebook. And honestly, I want to do a series of this where I look at some of the old infrastructures I've worked on. So Facebook's going to be first, but also we're going to do more of a SQL Server kind of look at, especially since a lot of people still use SQL Server as a key way of doing data analytics. And it just is a solid set of tools if you don't work on the cloud. And even if you do, there's a lot of good options there. So let's dive into this article. So like I said, we're going to now dive into Meta, or where I worked at their Facebook's data infrastructure, and kind of go through the different layers that they have and kind of talk about how they all operate. We can kind of skip the intro because obviously it's just saying what this article is about. Let's start with what they call a data warehouse, right? And they even kind of call it out that they're just calling something a data warehouse, but it really isn't the same probably as what most people would expect. So first, they call out the fact that, there is a distinction between the graph database that they have, which is often referenced as Tau, and their essentially exabyte data warehouse. It's so large, obviously, as they call out, is so large that it cannot be physically stored in one single data center. And I remember this, that I could look at some of the different teams that essentially existed, and some of their namespaces, which we'll kind of go into that here in a second, were so big that they'd be in the hundreds of petabytes in terms of like scale, especially like ads. In fact, ads might have even been beyond petabytes if I recall, but like ads, the main application data, those were huge. And then there were others that were obviously around it, maybe like the business data sets that were more in the terabytes. So why do they have namespaces? So part of this is that they're not all in the same place, right? Since the warehouse is not physically located in one single region, it is split into namespaces. Namespaces correspond to both physical, geographical, and logical partitioning of the warehouse. Tables that correspond to a similar theme are grouped together in the same namespace so that they can be used in the same queries efficiently without having to transfer data across locations. Another kind of key reason why they obviously have things in different namespaces, I'd call out, is because not everyone should access everything, right? There's certain data you want in specific places. Although you could obviously also do like some table, column, and they were working on row level security when I left. I don't know if they ever got it. I recall that project, like I was trying to use row level security, and the person that I was talking to, I gave them the project I had, and they're like, oh, actually don't use our solution. It's not going to work. But yeah, essentially we could think about it is it kind of looks, I mean, this is how I mentally think about it. This was something I recently posted where I kind of said there's like this ideal world versus, in reality. So Facebook's world kind of looks like this, where you've got different namespaces. This might be instead of core, maybe like ad data. And so everything was kind of near each other, but not really. Like you could move things in between namespaces. So maybe a better way of thinking about this is like these are all a little bit partitioned, essentially, like they're logically separate. And we would have this internal tool that if you wanted to move things in between places, we called it U-Haul. It was just a UI where you go into it, right, like a U-Haul truck, and you say, hey, from this namespace, get this table, D user, whatever the dim user, D employee, etc., and move it into the marketing namespace, right? Like that would be the goal. You just U-Haul it over, right? Where they kind of reference it here. If there's a need to use tables from two different namespaces in a query, then we need to replicate the data. Either we can choose to replicate table 2 onto namespace A, or replicate table 1 to namespace B. We can then run our query in the namespace where both tables exist. Data engineers can create these cross namespace replicas in a few minutes through our web-based tool that they will automatically be kept in sync. So this was really cool. So this is kind of probably very similar to Snowflake data sharing. At least that's kind of the feeling you had. It was really simple. Like they said, it's just a web UI. You just click a few things, name the table, and then you could click how often, I think, if I recall, how often you want it synced, but it was pretty much real time. So when something changed, it would change. While namespaces partition the entire warehouse, tables are also themselves partitioned. Almost all tables in the warehouse have a DS partition column. So if you've seen, I think, my data modeling video, I talk about this, how oftentimes a lot of tables, instead of having like slowly changing dimensions, they would just have date partitions that you'd essentially layer on top of each other forever. That's not true. I think we set it up to be 90-day retention by default. And so it would just kind of layer on top of each other, and that would be the way we looked at data historically. And they call that out kind of here, actually, even though they reference the 90-day retention period. So data is only retained in Meta systems for a period of time needed to fulfill the purpose for which the data was collected. Also, obviously, all tables are associated with an on-call group, which defines which team owns this data and who users should refer to if they encounter an issue or have a question on the data in that table. Now, this obviously is good and bad, right? On one side, it sucks if you're on call. Every team basically had an on-call rotation. But it was nice because I think I only had to be on call maybe every 2 months. And it was never bad because our team was not like forward-facing with the application. We were internal-facing. So if something went down, unless it was for a report that was like due the next day, you usually could just deal with it the next morning versus waking up at 4 a.m. and having to deal with the problem. But what's nice about it is that, guess what? If you had questions about a table, you had somebody you could go ask. And that's really nice, right? Like, if you've ever worked at a large enterprise, you know the pain it is to find who owns a table or any information about that table at all. It's very painful. So this was great. It just made it way easier. If you ever had questions about a table that wasn't yours, you could easily go and ping the person. Although occasionally someone would not update who owned that table and the person would have moved teams and you'll call out to them or reach out to them and they'll be like, we haven't touched this table in 2 years. So that did happen once or twice in my experience. So the next question is obviously, how is data written into that data warehouse, right? What actually gets it there? And you'll see kind of the main way that I used when I was there was what we call data swarm. Many of you probably have seen something close to Airflow, or many of you who are familiar with Airflow will probably recognize it. It feels somewhat similar. Logs, there was a lot of logs that you could literally just log tables directly to it, or daily snapshots of entities in the production graph database. So some people, again, literally just set up direct snapshots. We call them entities, but on the other side, right, it's a graph database, but it probably was a table on the other side that you're kind of taking a replica of or a snapshot of. I'm going to skip data discovery. We'll get back to this. I think a lot of you want to see something a little more specific and to data engineering. So I'm going to go down to data swarm really fast, and then we'll kind of go back up. So writing pipelines. I think this is what most people in data engineering like doing, right? We like data modeling, but I think a lot of us like building pipelines for one reason or the other. Data pipelines, as I kind of call out here, are mostly written in SQL, right? That was just the key part, right? Business logic was the key part. And that's a lot of what the pipeline was. Since we were consistent on the data layer we were working on, right? We didn't have Snowflake and BigQuery and Databricks where we were having to pull all this together. We could really just use this one layer of SQL and not have to make a connection to 30 different things because there was just essentially this one data warehouse that we were referencing. Namespaces were different, right? You had to make sure you were referencing the right namespace. It also depended on who the user was that was running it, because obviously you can't run a data pipeline on things you don't have access to, but it made it very easy. So you could just use SQL essentially. Once that data was there, it's there, and now you can just use SQL to interact with it versus something else. And they call it out here kind of that, the Python library we use for orchestrating and scheduling pipelines is internally known as Data Swarm, but it's the predecessor to Airflow and is developed and maintained internally. If you wish to learn more about that, you could probably go watch a video. I think they have this classic video that I think I often point out to people. So again, if you know Airflow, you know DAGs, and that's really all you're doing here. You're building a DAG. They call out a few key operators here that I recall. The wait for operator. So this generally, you'll see kind of here, it's actually right here at the bottom, essentially would wait for different data sets to load something like today's partition of data. So you could say, hey, wait on whatever table, and once a new partition for today has run, then you can run this next step. So it was literally paying attention to the table to see like, hey, when did something run? With the query operator, this was very easy to use because you could just switch between Presto and Spark without having to really think about too much in terms of like, what am I doing with Spark? What am I doing with Presto? Obviously, you want to use the optimal engine for whatever job you're running, but you're not having to think about the nitty gritty of Spark and Presto, as I think a lot of other situations you might have to do that. So that was the query operator. Again, that would just be like you'd reference, and I'll go below actually. You would literally just reference kind of this dependency list. So it says dependent list here. You could put the wait for operator. So that was this wait for operator up here. So if there was other things, you just put it there. If maybe there was another operator you wanted or task that you wanted to get done, you'd wait for it. You'd have the SQL and kind of where it's coming from. Again, some business logic. You'd be creating and often, insert overwrite is the way we would treat it. So you'd be overwriting the prior data partition if you happen to run it twice. This is why a lot of people talk about like idempotent pipelines, because these pipelines, like, they would just run, and many times they just would insert and overwrite. So you want to make sure that they act the exact same way every time. You don't want them to change because it's going to rewrite whatever you had in the past. But that was generally more of the query operator. It really is what it says. You just put some SQL here and then put a few config points afterwards. Data quality operators were also kind of great. They were really nifty. you would just have a set, I don't remember, there's like 3 or 4 that you could toggle around. Some of them would do basic things like counts. Some of them you could make more of a custom check. So if you had something where it was custom and you wanted to say based off of a certain number or count or some other type of check, you could literally write a query that would run against it. And if, let's say, that number or whatever exceeded 5, maybe the total count of a certain category exceeded 5, you could then flag this as a fail. And then from there, you could also add in a little tidbit that said, if failed, stop this pipeline or just, give me an update. But those were definitely the ones I used the most often. I don't think I ever used a data transfer operator. I would have a few miscellaneous ones. We had to build a few of our own too. Occasionally you had to build your own operators. Like there was an SFTP operator, but it didn't work that well. So we just had to build our own. And I think no one ever really truly fixed it. And since we already had one that was kind of built and we were kind of using, we just used our own instead. And so we can kind of go below, and I've already talked a little bit through this pipeline, but you can see you've got config set in terms of schedule, be daily. You'd also add like who was running it, like what team should be running it. You shouldn't have it running on a person. It should be running on a team so people know who to go to. You'd also obviously put in things like dependencies. You'd have a wait for operator, but you might also have something like an end of pipeline or ready operator from a prior task that you want to link to it. You can literally see the VS Code extension here. This is what it would look like. This was actually later on. I think either early on I didn't find this little feature in VS Code, or I think they added it later, because when I started, I want to say we were using Atom. And then somewhere later on, they switched to VS Code. What I really appreciated about everything at Facebook was how well integrated things were. Like your VS Code UI that you would use made it very, very easy to see kind of, oh, here's my various PR requests, and it's or diffs as we called them. And here, you could literally get comments inside your VS Code environment. And obviously, there are still people who preferred using Vim. My manager was one of them, loved using it. Even though now I can't remember if he used Vim or Emacs, but some people preferred using more traditional code editors. But a lot of people at Facebook used VS Code. I do like they called this out at the end. If there is an error in any of your SQL statements, they had a custom linter that would kind of call it out. Also, whenever you saved anything, they had like a formatter, and everything was very, very clean, and it was nice. Now, the next thing that they reference is this UPM. So this was something that was added later. Like I recall people like talking about UPM, but it was this slow kind of push for adoption. So I'll read through this, but I did not use UPM when I was at these. So if you reread the code above, you may notice that there's some redundancies in it. In this example, we asked the first operator to wait for today's partition, to land for my data source, and in the second operator, we ask the framework to wait for my operator 1 because we need the date ID partition, so that data from partition 1, to exist in the staging table. But we can somewhat already infer this just by looking at the SQL query where ds equals date ID, which implies that we depend on the date ID partition for this table. And as engineers, we don't like to repeat ourselves. And this was something that was very common at Facebook. If you saw something like this where you're like, hey, we could even just improve or remove like 10 lines of code somewhere, that would be such a benefit. Like if you could remove 10 lines of code that in something that was repeating over and over again, those were things that would arguably get you a promotion, right? Because now you're writing code faster. Now you can get to the actual crux of value, which is not writing queries for no reason, but like talking with the business, understanding the data that they need, and helping them build and iterate really quickly on products versus, just writing queries for the sake of queries. So a team of engineers at Meta tackled this problem and built a framework called UPM, or Unified Programming Model, which does exactly this. When used in data swarm pipelines, it parses SQL queries in the operators and correctly infers which partitions each operator needs to wait for. With the use of UPM, all the wait fors and dependencies can be automatically inferred in terms of the pipeline, and that can be reduced in terms of core business logic. So yeah, that's kind of cool in terms of what it's doing. So here, it is just inferring a lot more, right? Like it knows, hey, because you're asking for this DS, I know, in terms of dependencies, what to expect. So it's kind of nifty. It's a nifty little trick. I think the one risk here, right, and this is always, as things get more complex, this is always the risk. The more you make things implicit, so it's like, you have to know what UPM is, the more abstract and hidden away things are. So this is always an interesting discussion we had at Facebook, which was like, how far is too far in terms of like layers of abstraction or putting, new layers of code on top of new layers of code. Because eventually you don't have a lot of control, and that can be a little frustrating, right? So there is this kind of interesting balance and discussion sometimes where it's like, what is too much and what is too little? I'm not saying this is too much. It's just, this is nifty, but I think it's always worth talking and thinking about like, what is too far in terms of abstracted away of work you should be doing and thinking through, because it will make your code better versus like essentially lazy loading or lazy letting things do things for you. So just an interesting point that I thought as I was reading this. So scrolling back up, we're talking about kind of the engines that we would use to query the warehouse. Again, the warehouse is just a bunch of Hive tables that exist, but on top of that, we would run Presto and Spark on top of it. And this is kind of the world that I see that people are trying to build now, right? This multi-engine data warehouse where everything's in these days Iceberg or Delta Lake or something similar, and then you have all the engines that call from it. I will say one of the reasons I think this worked really well at Facebook was because we were really good at defining what table was the table. Like, I've worked with clients that they can't decide which table or which company, because there could be multiple entities inside of, large enterprises, should own the customer table. Instead, they have 10 different customer tables with slightly different definitions, and it makes it really hard to move forward. Some of this is probably because Facebook's business was digital, so it's a little simpler to kind of see how things operate, right? Like, it's very clear that ads are a big part of it, so it makes the entities very clear. But some of it, I think, was also due to the fact that they had a very mature infrastructure and a very mature set of processes that they made sure everyone knew from day one. Like, when you go through onboarding at Facebook, you learn about the user table, you learn about the employee table. Like, these are the core tables, you know that they exist. You don't wonder, hey, how do I find users? How do I find these specific tables? You know that this is the table. There are no questions asked. I think at one point they did go from one user table to another, like they made a giant migration. But other than that, like, that's the table, right? We're not going to have lots because that's confusing and it's not consistent. Again, some of that's probably because the business model might be a little more straightforward. But because of this, right, we were able to essentially just pick which engine we wanted to use whenever we were writing a query. So Meta maintains their own internal fork of specifically Presto. So it's developed there. This now has Trino as well. That there's an interesting story there as well. But again, going down and reading through this, right, with our focus primarily on business impact, design, and optimization, most of our pipelines and queries are written in SQL in one of two dialects, Spark SQL or Presto SQL. Although we leverage Spark's Java, Scala, and Python APIs to generate and manage complex transformations for greater flexibility, this approach provides a consistent understanding of the data and business logic and enables any data engineer, data scientist, or software engineer comfortable with SQL to understand all of our pipelines and even write their own queries. More importantly, understanding the data and its lineage helps us comply with the myriad of privacy regulations. Yes, that is obviously. I feel like there's a few points here in this article that they're clearly like, hey, just to let you know, we're still complying, with whatever in terms of GDPR, security, compliance, because they did, get in a lot of trouble in 2018. And then again, a few other times, I'm pretty sure. The choice of Presto or Spark depends mostly on the workload. Presto is typically more efficient and is used for most queries, while Spark is employed for heavy workloads that require higher amounts of memory or expensive joins. Presto clusters are sized in a way that most day-to-day ad hoc queries that scan generally a few billion rows, which is considered a light query at scale. They're just like, just to let you know, that's nothing in our world. Produce results in a few seconds or minutes if there's complex joins or aggregations involved. So yeah, that is kind of true. You could literally, whether it was in DataSwarm or later on, they reference Bento or DieQuery, which is kind of the way that you would interact directly with ad hoc queries. So your general like SQL editor that you could actually run queries against these various data sources. You'd be able to just click a little button and say like, I choose Spark SQL, I choose Presto SQL. And they let you pick which one worked best depending on your jobs. And most of the time, at least in my case, when I worked there, it was always Presto. It was almost always Presto. I think Zach might have had a post somewhere where he said like Spark is the future. It just depends on the company. I think a lot of people will use Spark, but again, here in this case, Presto was heavily used. I think another interesting thing that they call it here is the fact that data engineers, data scientists, and software engineers all could build data pipelines. And this is very different than, for example, Airbnb's Notion, at least what I've understood from Zach, where they use Scala and they kind of had this threshold where like, we want to make it as almost hard as possible. We want to make this process very difficult. They tried to have data scientists and software engineers build data pipelines, and it just became kind of a cluster. So they actually went the other way and tried to make it very difficult, try to have like clear reasons why you build tables. You actually have to go through the process of putting together like a design doc. I think they called it something else, but something very similar to that, to make sure you called out like, hey, this is a valid table. This isn't just something I'm building for ad hoc purposes, which I think is fair. So I just think it's interesting seeing these two different approaches in terms of like how you handle data and who can build things. Now, going up really quickly, and I think we're going to wrap this up because this video is getting long, but I'd love to know if you'd like me to go more in depth on these types of articles, is data discovery and data catalogs. I think this was super key to being just efficient at Facebook. It was really just around finding the data that you needed and having a tool that was really good at that, which in Facebook's case, they called iData. Just made my life so much easier. You'd literally just be typing in some general terms of data you want, like Asana, something, data sets, and you'd find it, usually. And you'd be able to see who is using it, how often it's being used, what dashboards are using it. You could kind of see the query. You could follow the lineage. It just did everything so well that you didn't have a lot of questions. I think this was a key reason why people didn't often build duplicate tables. There were duplicate tables, but this definitely improved it. So when dealing with such a huge warehouse, finding the data needed for analysis can seem like trying to find a needle in a haystack, and yes, it can. Everyone knows that they've opened up a data warehouse and seen thousands of tables. I have small companies that I work with that have thousands of tables that you have to kind of go through and be like, you don't need this, etc. But that's where this was helpful. Thankfully, engineers at Meta developed a web-based tool called iData, in which users can simply search a keyword, and then iData will then find and display the most relevant tables for that keyword. It is a search engine for the data warehouse. iData ranks search results in an intelligent way that generally finds you the table that you were looking for in the top results. And I would kind of agree with that. It really did feel like it would find the table often. Occasionally, you'd have to do a little searching, but you'd find the core tables, because it was also like based on how people were clicking, who was using it, how often it was used. It went a lot more in depth than just, hey, here's a thing that kind of sounds like the name you just told me. To display the best results, it takes into account several features of each table: data freshness, documentation. Documentation is interesting because oftentimes if you didn't fill out enough, you would actually get pinged eventually from like an automatic task system that would say, hey, we noticed you haven't finished documenting this table. Please go back and add in PII, add in like column descriptions, add in table description, etc. So that was always key. They literally would make us go through it and ensure we document it correctly. Again, number of downstream usages. In ad hoc queries, other pipelines, or dashboards, typically a table that is used in many places can be seen as more reliable. The number of mentions in the internal workplace, that I didn't know. That's kind of cool. Although workplace, I think they're shutting down what they're selling, so I don't know if they're going to keep it alive internally at Facebook, but yeah. And the number of tasks associated with it. Yeah, I didn't know those last two. I figured it was just based on like usage, but that's kind of cool. It can also be used to do advanced searches, e.g. search for tables that contain specific columns that are assigned to a particular on-call group, and so on. iData can be used to find other types of data assets in addition to tables, such as dashboards, and includes lineage tools to explore upstream and downstream dependencies of any asset. This makes it possible to quickly determine what pipelines are used to produce data for high-level dashboards, and what logging tables sit upstream of those. Yeah, so that was always helpful. I mean, every once in a while you'd open up a data lineage and it'd be like 30 like DAGs deep, essentially. So like 30 different files. I definitely saw that more from the machine learning engineers. I recall opening one that I think was just for parsing resume information out, and they were so long because they were trying to standardize naming, right? Because the fun thing is, if someone puts in Harvard, do they mean Harvard University? Like there was like Harvard Middle School, Harvard boating club, and you're trying to parse all this information out and standardize it, right? Someone might put it various ways. Some people might just write Harvard, some people put Harvard University. And from an analytical standpoint, you want that all to be, a single value. So I remember like those pipelines would be very, very long. Just try to, standardize the naming there. Although maybe LLMs help these days. I'm sure they make things much easier versus trying to do some weird logic to make it all match. So those are some of the key components that we had at Facebook that made our lives easier, right? There weren't a ton of crazy components. I think what's interesting is, I've put up data infrastructure that tries to replicate some of these components. In fact, this chart, which isn't really a baseline, was kind of used when I was talking to someone who was transitioning outside of Facebook to try to cover through what means what in everyone else's world, right? Right? Like Airflow, I told them, was like Data Swarm. We didn't really have different EL tools, right? Like your operators would act, like I call it here, Airflow operators, Data Swarm operators, would essentially act as your extract layer. Same thing here, where it's like Airflow would really just do the transforms. You wouldn't have any tool here. And so it was really simple, clean, sleek, and just made it very easy to like put out data tables that were reliable quickly. So you don't need 30 tools every time. I think a lot of people do more with less. For anyone who's trying to figure out what infrastructure you need, you can have Airflow try to orchestrate 30 different tools, or you can honestly just use something like Airflow or more, updated version or more improved version of some of the modern orchestrators to do some of these tasks, or you could just use SSIS. Honestly, that works great too. There's so many options. But honestly, I think it's cool that Facebook put out that article talking about what data infrastructure exists under the hood at Facebook and how they manage and process exabytes of data. With that, guys, I want to say thanks so much for watching this video, and I will see y'all in the next one. Thanks all. Goodbye.